Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Balloon and Kites in the Fog by Carmen Lambert, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is a box. We have adjacent digits along a green German whisper line must have a difference of at least 5. So, for example, if this were a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are specifically 8 and 9. And that's an example of how German whisper lines work. Digits along a magenta line, Renban, form a set of consecutive, non-repeating digits in any order. So, for example, these 4 digits must form a Renban. So you could have something like, say, 2, 5, 4, 3, and 4 here. And that would satisfy that Renban line because they form a set of consecutive, non-repeating digits. And that's an example of how Renban works. We have digits along a blue line create a sum line where the sum of digits on the line within a particular 3x3 box must be the same for all the boxes the line passes through. I'm not a big fan of the way of the wording of this. Usually like to say is that the region borders break up the blue line, the region sum line, into segments which must have the same sum. That's the way I like to do it. So say this blue line here went something like, this is edge only, let's go here. So say it went like that. Then the sum of these 3 digits would have to sum up to what that digit is there. And that's an example of how region sum lines work. We have digits along a dark orange Dutch line must have a difference of at least 4. So similar to German whisper lines, if, for example, this were a 3, this would have to be 7, 8, or 9. Because these two, the only digits which are 4 or more away from 3 are 7, 8, and 9. And that's an example of how Dutch lines work. Digits along a light orange parity line. So this is, I guess I call it peach line usually. But must alternate between odd and even. So for example, if this were, say, a 2, this would have to be an odd digit along this line here, because you must alternate parities between adjacent digits on the parity line. So this could be something like 2 and 7, and that would be valid for these 2 cells along the parity line. We also have a V between 2 cells mean they add up to 5. An X between 2 cells mean they add up to 10. So assume we had a V here, which is the blue mark, and an X here. If this were, say, a 3, this would have to be 2, because these 2 digits would have to add up to 5. If we had, say, a 6 here, this would have to be 4, because these 2 digits would have to add up to 10 if there was an X there. And finally, the board is covered in fog. Place a correct digit, and the fog will lift around it. So if you place a digit correctly, say like in this cell, it will clear the fog in that cell and the 8 surrounding cells around it. So that's how you can get more information about the rest of the puzzle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so this is kind of a mess here in the middle. What we do know, though, is on a German whisper line, you can never have a 5. And the reason why you know that is subtract 5 or more from 5. what do you get? You get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. Therefore, 5 can never be on the German whisper line in normal Sudoku. So this must be a 5 here. So that's 5. What else do we know? These two are the same digit. Okay. So we know that for certain. This is the same digit as this. I don't want to color because it's too many things going on. So we're going to mark it with the A. Because these segments must sum to the same total. This has to be a renban. So it's 2. It could be 2 through 5, 3 through 6, 4 through 7, or 5 through 8 to include the 5. So this is 2, 3, 4, 6, 7, or 8. On a German whisper line, you'll alternate between low digits and high digits. And how you figure that out is if you have, say you had a digit from 1 through 4, what digits can be next to it? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9. So if you have a low digit, which is 1 through 4, it'll always be next to a digit from 6 through 9, which is a high digit. Same and vice versa. If you have a 9, it can only be next to 1 through 4, 8 can only be next to 1 through 3, 7 can only be next to 1 or 2, and 6 can only be next to 1. So if you have a high digit, it'll be next to a low digit. So we can start coloring in lows and high digits on... Well, we can choose, essentially, one set to start with, and then mark the other set as the other set. So we're going to mark this as orange. Oh, there's too many colors going on around here. Orange and yellow. So this is orange, this is yellow, this is orange, this is yellow. This must be orange, which makes this yellow, and this yellow. That makes these orange, which makes this yellow. That means these are yellow also. And this is yellow, because they're next to an orange on the German whisper line. Interesting. So these are different sets. So you can never have 2, 3, 4, 5 or 5, 6, 7, 8 because they would be in the same set. So this cannot be 2 or 8. Therefore, if these are either 3, 4 or it's a 6, 7 pair here. What digits can be next to 3, 4, or 6, 7? Well, first of all, we see a V here. The only digits can be next to a V are 1, 4, or 2, 3, adding up to 5. So these must both be low. Therefore, since this is low, all the yellows are low. And all the oranges are high. So this cannot be 3 or 4, it's 6 or 7. That forces this to be 6 or 7. This is also 6 or 7 because these sum up to the same sum. This has to be 4, 5, 6, and 7. So this is 4, which forces this to be 9 to be next to it on a German whisper line. 6 and 7 can only be next to 1 and 2 on a German whisper line. So this is 1 or 2, this is 1 or 2. That means this digit has to be able to be both next to 1 and 2 on the German whisper line. So this must be 7. 6 can only be next to 1 digit. So this is 7, this is 7. That makes this 6. This has to be 3 and 4 to add up with a 1 and 2 to add up to 5. 6 can only be next to 1. So this is 1, which makes this 4. That makes this 2. So this is also 1. This must be a high digit because it's on a German whisper line. And this is on a, well, we don't know how far that red man goes. 7 can be next to 1 or 2 on a German whisper line. And this can't be 1 because of the 1 in the row. So this is 2. This has to be an 8 because that's the only remaining high digit. So this must be 1, 2, and 3 here. 1 cannot be on the Renban with 1. 2 cannot be on the Renban with 2 because you can't have repeats. Okay. Peach alternates polarities. So this cannot be 2, it cannot be 4. This has to be 6 or 8 here. Or sorry, parities, not polarities. So this is odd, which makes that even. Well, if this were 8, this Renban would have to be 7, 8, or 9, but that would eliminate the 7. That's eliminated because of the 7 in the box. So this can't be 8. This has to be 6. This must then be 5 and 4, respectively, to be on the Renban with it. That leaves the remaining digits to be 3, 8, and 9 in the box. And they're all on a Dutch whisper line. 5 can only be next to 9, so one of these is 9, so this can't be 9 here. The only digit that can be next to both the other digits on a Dutch whisper line is 3. So this must be 3, and this can't be 3 here. Also, 3 couldn't be next to 4 or 5 on a Dutch whisper line. So this is 3, which means this can't be 3 here. This is low, so this must be high. This is low, so this must be high. So that makes these low on the German whisper line. 4 can only be next to 8 or 9 on a Dutch whisper line. So this is 8 or 9. This is high then, which forces all of these to be low, because they're all next to a high digit on a German whisper line. This must be 3 because it can't be 1, 2, or 4. That means this is a 1, 2 pair here. This digit cannot be 1, 2, 3, or 4. It must be 5 through 9, and it's on the Renban. So, okay, these two digits add up to 10. It cannot be 1, 9, 2, 8, or 3, 7. So this must be a 4, 6 pair. These are high digits. We have to be 7, 8, or 9 here. We're not sure which. The remaining digits in row 4 must be 5, 7, 8, 9. And 5 has to be one of these two digits here. This alternate parity with the 4, so it must be an odd digit. It cannot be 1 or 3 because of the 1, 2 pair in the box and the 3 in the box. So it's 5, 7, or 9. Cannot be 5 because of the 4, 5 pair in the row. Remaining digits, oh, this can't be 7. So the remaining digits in row 7 have to be 5, 6, 8, and 9. Okay. So this must be a high digit because it's on a German whisper line. Can't be 5, and this must be a low digit. And it cannot be 4 or 2, so this is 1 or 3. Okay. 6, 8, or 9 on a Dutch whisper line can only be next to 1, 2, 3, 4, 5. Well, 5 can't be here because of the 5 in the row, so this is guaranteed a low, so this is 1, 3, or 4. This is also next to another Dutch whisper line. We don't know what that is, though. 1 can be, no, 1, 3, 4 can be next to 5, 6, 8, or, well, we already know it's 5, 6, 8, or 9, so that's fine. What are the remaining digits in this lower left-hand box? It's 5, 6, 7, 8, 9. And this 8, 9 pair in row 9 eliminates 8 and 9 in the rest of the rows. This can't be 8, 9. It's 5, 6, 7. 8 and 9 can never be on a 4-length Renban with 3 or 4. So this could be, it cannot be 5 or 6 because of the 5 or 6 in the row. 3 and 4 can only be 1, 2, 3, 4, which this can't be 1 or 2, so that doesn't work. 2, 3, 4, 5, which could work. 3, 4, 5, 6. And this can't be 5 or 6, so this must be 2, 3, 4, and 5. That means 5 cannot be here. This is 6, 8, and 9. 5 can't be either of these cells because of the 5 in the box. So this is a 6, 7 pair, which eliminates 6 and 7 in the rest of the box. This can't be 7. So this is 9. That makes this 8. What are the remaining digits in row 8? They have to be 1, 2, 3, and 7. Remaining digits in row 9 have to be 1 through 5, but no 3. So 1, 2, 4, 5. Okay. We don't know where this Ren's bands go to. This is an odd digit because it's 1 or 3, so this must be an even digit here. So this is 6 or 8. That means this is an odd digit to be on the peach line, so this can't be 4. This is 1 or 3. This 9 eliminates 9 here. Oh, these are the same digit because they are 2 parts of the region sum line. And so these are different regions, so that's 8. These cannot be 8 here. This is a low digit, which makes this a high digit here. 8 can be next to a low digit on a Dutch whisper line, so it cannot be 1, so this is 2, 3, and 4. 2, 3, and 4 must be next to a 6, 7, 8, or 9. Cannot be 6 or 7, so this is 8 or 9 here. These two are different parities than this digit. We have 2 odd digits and 1 even digit. Therefore, this must be the even digit. This is 2. That makes this 3, which makes that 1. This must be a 2 to form the Ren band with 1 and 3, so that's 2. This can't be 2 or 3, so this is 4. 1 and 3 are odd, so this must be even, so this is 8. This is high, which forces this to be low here, which forces this to be high. It cannot, this is low and 3. This is high. That means the remaining digit is high here. So this is 9. This is 9. This is 1. 1 has to be next to 6 or 7. This cannot be 6 because it's next to 2 on a German whisper line. So this is 7. This is 6. That makes this a 1. We had the region sum line adding up, so that's 1. 8 has to be next to 1, 2, 3, or 4 on the Dutch whisper line. So this is low, and it's a 3, because it can't be 1, 2, or 4. This could be 7 or 9, so that's fine there. This 1 eliminates 1 here, so this is 3. 3 cannot be either of these. This is on a German whisper line, so it must be low. Cannot be 5, because it's 1, 2, or 4. Therefore, this must be a high, and it must be 7 then. That makes this not 7. This can't be 4, because it must be a 1, 2 pair to be next to the 7 on the German whisper line. This Ren band forms a 1, 2, 3 set. 3 cannot be next to 6 on a German whisper line. This 1, 2 pair eliminates 1 and 2 from the rest of the box, so this is a 4, 5 pair. This 6, 8 is a different parity than this. So this is even, that makes this odd. So this is 9, this is 8. That makes this a 6. And we see the balloons and the kites. So these are the kites, and this is the balloon in the fog. Interesting. Anyways, we don't have any restrictions there. This can no longer be 9. This can't be 7. 1 and 3 both work on a Dutch whisper line with 8 and 9. Actually, they work on a German whisper line set with. Anyways, I think the rest we're gonna probably have to do with normal Sudoku. Okay, so this 8 eliminates 8 here, so that's 9, which makes that 8. 4 eliminates 4 here, so it's 5, which makes that 4. Last remaining digit in column 4 is a 2. And last remaining digit in column 6 is a 5. Okay. Remaining digits in row 3 have to be 5, 6, 7, 9. Okay, so this can't be 5 because of 5 in the column. This can't be 6, 7. We have a 5, 9, 5, 9 pair in column 7. This can't be 9. That eliminates 5 and 9 in the rest of column 8. So that means the remaining digits are 1, 2, 3, 4, and 8. This can't be 1, 2, 4, or 8, so that makes this a 3. Which means this can't be 3, this is 1. That makes that not a 1, so that's 2. That forces this to be a 4, 8 pair here. This 2 eliminates 2 here, so that's 1, which makes this 2, which makes that 1. Also, we had the orange parity line, so this had to be different parities. So we could have gotten that, I guess. What else? Remaining digits of row 5 have to be 5, 6, and 7. But 6 cannot be here because of the 4, 6 pair in the box. So this must be 6, which forces this to be a 5, 7 pair. 5 can't be here because of the 5 in the column. So this is 7, that's 5. That means this can't be 7, this can't be 6. Remaining digit in the left... Okay, this can't be 5. Remaining digits in this left central box have to be 3 and 9. And this can't be 9 because of the 9 in the column, so this is 3, that's 9. Remaining digits in row 6 have to be 4 and 8. This can't be 8 because of the 8 in the column, so this is 4, this is 8. This 4 eliminates 4 here, so this is 5 and 4. We have a 5, 7 pair remaining in column 9, which eliminates 5 and 7 in the rest of the column. This must be a 2, 3 pair. 2 cannot be here because of 2 in the row, so this must be 3, which makes that 2. That's 3 in the corner. We celebrate because we know we're getting close to solving this. Remaining digits in column 7 have to be 6, 7, and 9. And this cannot be 6 or 7 here because of the 6 or 7 in the row. So this must be 9, which makes this 7. That makes this 6. 7 eliminates 7 here, so that's 5 and 9. This 9 eliminates 9 here, so it's 5, which makes this 7. That means this can't be 7 here. This 9 eliminates 9 here, so that's 6 and 9. This 6 eliminates 6 here, so it's 4 and 6. 6 eliminates 6 here, so it's 7 and 6. Okay, remaining digits in column 1 are 1 and 8. This can't be 1 because of the 1 in the row, so this is 8 and 1. 8 eliminates 8 here, so it's 4 and 8. That leaves these digits as 3 and 5. This can't be 5 because of that 5, so that's 3 and 5, and we have 4 and 7 left. So that's 4, and that's a 7. Yay, you completed the puzzle. Okay. Click on the back arrow and click on the word here to see the picture without numbers. Okay. Anyways, very cool puzzle. Let's see, where's the here? Click on here. I don't see here. I clicked back. I don't know. Oh, it's probably in the... It's in the post, probably, that you can see the picture without the Sudoku rules marking. Anyways, I hope that makes sense. It was pretty straightforward. There was a lot of lines in the first amount, so that was kind of hectic, but it's not that hard to figure out, basically, from there. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.